Number 7, a point moves along the x-axis in such a way that its velocity, so first derivative, at time t, when t is positive, this is just saying negative time does not exist, is given. So this is my function. Understand that this is the velocity function. This is your first derivative. At what value of t, so at what t does v, this function, attain a maximum? Remember, when I want to maximize or minimize a function, I need to take its derivative. So v prime will give me, well, what's the derivative of what you see? I will use quotient rule. It's the bottom squared, and it's low d high, so the derivative of the top is 1 over t, minus high d low. Now d low, the derivative of t, is what we're in respect to. It's just going to be 1. So this simplifies out to 1 minus natural log of t over t squared. This is my derivative. And I want to see when does it attain a maximum. So I need to find the zeros of this function or the critical numbers of this function. So by looking at this, the critical numbers will occur when the derivative of the said evaluated function is undefined or 0. So if I set this bottom equal to 0, that will make it undefined. So I know one of my critical numbers is 0. Now when I set the top equal to 0, it's to try to see where are my slopes going to equal 0. Not undefined, because that's what the bottom was, but where are they going to equal 0? So I'm going to set 1 minus natural log of t is equal to 0. Therefore the natural log of t is equal to 1. Well, what is t equal? The natural log of something equals 1. Well, t is going to equal e, because those cancel out and I get 1. Let's say you don't remember that. I can rewrite natural log as log base e of t. And from looking at this from reverse Hart method or methods that you learned in pre-cal and algebra 2 with exponentials and logarithms, you can use my shortcut to convert from a logarithm to an exponential, the reverse Hart method. So you start with the base, you go over here to the other side, and you rewrite e to the 1 is equal to t. That's how you know your answer is e. Now we're going to verify real quick with the number line test. Our critical numbers were 0 and e. So in my derivative, let me pick a number less than 0. As soon as I do, I need to identify that won't work with the natural log, because my natural log function, parent function wise, is like this. Its domain is where x is greater than 0. So I can't have a negative number. It's undefined in this interval. So if I put something in between 0 and 2.71828, because that's e, let's say that we put 1. 1 minus the natural log of 1. We know natural log of 1 is 0. So 1 minus 0 over 1 is equal to 1. That's positive. And then finally, anything after e. So anything after e is going to show, so here's 1. And say e is over here because it's 2.71828. Here's my y value of that. You're going to see that, so the y value of natural log of e, because this is the natural log of x function, the natural log of e is 1. So anything past that, you know it's going to be greater than 1. So the natural log of something bigger in this interval is going to make my denominator negative. The bottom is going to be positive no matter what, because it's squared, and that quotient is going to give you a negative answer. Here's the maximum. First derivative test. Positive to negative, increasing to decreasing, your answer is just e.